My name is Piotr Przybył, and I'd like to show you what it is all about the context. So it means CONTEXTVS is a clear reference to electoral campaign of Bill Clinton from 1992, as far as I remember, and it means more or less context stupid. He had economy stupid because he believed the economy is the most important thing, or worse at the time. I think context is very important, and I'd like to show it to you during this talk. Who am I? So I am remote freelance software gardener. If you don't know who software gardener is, you should read Pragmatic Programmer, also due to other reasons, but this is one of them. And remote freelance means two things. First, that if you have any issues, you can try to hire me, and also it's an answer to a question, where do you actually work? So my workplace is where I live, my sleeping room, the second door to the left. This is where I work. And you can send your hate here. Okay, a little agenda for today. So we'll start with some real-world examples, and then I will talk about some IT world dilemmas, and we'll end up with two simple how-to techniques. But this is a warning, a disclaimer. Who knows what caveat emptor means? Caveat emptor, maybe you've heard of it. Not so much. Okay. So it was a rule in ancient Latin, in ancient Rome law, and it's still present in nowadays law systems, like in the United States. Say you want to buy a house. So if you are a buyer, a taking party in the transaction, you need to make sure that everything is okay with the subject of the transaction, the house. It's not the seller's responsibility to assure you the house is fine. It's yours responsibility as the buyers to know the house is okay. Caveat emptor means let the buyer beware. Therefore, today's disclaimer, caveat auditores. Let the audience beware. So it's on you. But before we begin, I want to play a little game with you guys. I want to play a game with you, sir. And with you, and with all of you. We all play in this game. Relax. So this is a game. Nobody gets harmed except me, as you can see. We have this situation. This is our context. This is the crossroads, two cars. And let's assume, okay, for a minute, this is not one of these stop harm situations. Okay? So which car can go first? Blue one. Okay, who says red one? Okay, still some folks voting for the red. Okay, why blue one? Yes, because of this sign, give way, means that the blue one has a privilege and can go first. Okay, let's change the context slightly. Now, who can go first? Red one, why? Yes, exactly. Like the countries which recognize the Vienna Convention of Road Traffic have a rule that if there is like crossroads without any privileges like traffic lights or signs, the car or the driver who has the right hand free can go first, can go through the crossroads first. So because of the right side traffic, we have the right hand rule, more or less. Let's change the context. Who can go first? You say blue one. Still red one. And any other answers? Exactly. I throw, you catch. Exactly, that's the answer. It depends on the context, because it depends on the location of the crossroads, the country. Like there are some countries in Asia where they still have right-hand rule, despite driving on the left. In the UK, there's no right-hand or left-hand rule, as far as I know. It's like they're both responsible in the same way. And they have to agree. There is no privilege. If there is a collision, a crash, they are both responsible. There are some countries which have this left-hand rule. So as you can see, it depends. We didn't change the crossroad. We didn't change the direction of the cars. We just changed the rules. We just slightly changed the context. So remember, 1/4 of the world's population is driving on the left side. So when you implement this AI driving, okay, make sure you know the GPS location and stuff, in case I'm in the car, please. So guys, context exists. Turns out a context exists and we have to go and find it. We can't guess it. We can't assume it. We can't calculate it. As you have seen in this previous example, we have to find it. We need to know in which country we are in, basically. And we can't assume it because we have a right-hand rule, they have left-hand rule. Okay, 169. Is that far? Is that far? It depends on context. Now we have another highly paid consultant in the room. Very well. The unit is kilometers. Where's the scale? We are in space. We are in space. Let's assume this is a continuation of the first talk. It still depends, yeah. Sometimes it's not enough. See, the end of the previous century, there was a mission. It was called Mars Climate Orbiter, and the probe was sent from Earth. It traveled to the Mars, and it was on this trajectory, and it was supposed to start the maneuver engines just to jump a little and enter the orbit of Mars, just to observe its climate. Turned out that when this probe entered so-called radio shadow from the Earth, we lost the signal, and we didn't get the signal back. So after like 2 or 3 weeks of investigation, some folks found out that most probably, instead of this planned trajectory, the probe entered at the lower altitude, which means it disintegrated in the atmosphere due to atmospheric stress. Because, I mean, the atmosphere, there's almost no air on Mars, but still there is some air, which means the probe got disintegrated, most probably burned or got into the pieces and has fallen down on the surface of the planet. Which means this mission was a failure because of this gap. Even more, the safe threshold was 80 kilometers. So if there were like 90 kilometers, most probably it would start orbiting. Why did it happen? Because NASA had contract with Lockheed. And Lockheed, they are in aviation, so they didn't calculate in metric units like meters, newtons and stuff. They kept using imperial system. So one sensor was sending, let's say, 12, and the computer received 12, but the sensor meant 12 pounds, and the computer understood it as a 12 newtons. That's why there was a difference in trust, and then the whole thing disintegrated. Now, this picture was taken, as far as I know, 2 weeks before approaching the planet, just to make sure everything's okay, with the cameras and so on. And this is the only picture from this mission. And this is the actual size. And this dot here is Mars. And the whole mission costed, like, as far as I know, 330 American dollars, millions American dollars. 330 million. And this is the only picture. I think this might be the most expensive picture taken by humankind ever. So as you can see, skipping the context can be expensive, sometimes very, very much. It costs us money and time, of course. So how fast the light travels? Exactly, we have another answer, another expert. Sorry, it actually depends, because instantly people think, because this is what we are taught at school, 300,000 kilometers per second, right? This is what they think. Speed of light, 300,000 kilometers. But it's in this space, in vacuum. In the air, it's more or less 90 meters less. And it's not even an order of magnitude, so it's still safe. But in a diamond, due to refraction, it's more than 2 times slower. So if you work in diamonds or optics or like fibers, then it really matters to you where the light is traveling. Therefore, we need to make sure that the mantra we have in our mind from the school, 300,000 kilometers, it really matches our context. Okay, what do we see here in this picture? This is Cape Canaveral, Florida. This is a starting platform for space shuttles. This is a space shuttle, Columbia, I believe. And this shuttle is attached to a huge bomb called main fuel tank. And there are 2 smaller bombs on sides, which are called the boosters. And the whole trick is to not to explode the bombs instantly, but just to make them explode slowly and in timed manner. Therefore, using these bombs, the space shuttle could go into the space. Question, because many people are wondering, why is this bomb so huge and these bombs are so small? We could go more like the Russian way, right? Like a huge main rocket with boosters around it. Why is it working so? Some say it's because the boosters are made or fueled by solid state fuel. It's not liquid in here, it's like a solid state fuel. So the boosters are made in Rocket City in Utah, as far as I believe, and they are transported by rail. And the railway network has a nice property, which is called the structure gauge. And the gauge is more or less this. It's the maximum size of the train that can fit into. Okay, but why do we have this size of a tunnel of the whole railway network? Some say it's because the first builders of the railway came to the US from UK, and when they were building trams, they had to make the tracks in a way which allowed the trams to pass each other in the narrow streets of London City. Okay, but why the streets in London were so narrow? Because it's really an ancient city. And the streets were planned in the city by ancient Romans, and some say they had a law which meant that two double-horse chariots had to pass each other without interfering. Therefore, you know, if you had such a beautiful stallion like this one, 2,000 years ago, you had a road, then you had trams, then you had trains, then you end up with a booster of this size. So as you can see, sometimes you can't alter your context. You will not rebuild the half of your railway network for one single purpose, and context can live long, sometimes very long for millennia. All right, another example. This is about an open space. Not this one, I believe it's in Moscow, but let's imagine a huge hall, more or less like 30, 40 years ago, in kind of a Stan or other country in Far East. And they were hiring people as data entry clerks, meaning they were like human OCR at the time. So you had paper forms, and the paper forms had to be typed by someone into a computer, basically. And they had rows of desks, just one row, another one, another one. The whole room was packed with desks and people working as data entry clerks. So, you know, the smart guys in the Western world thought that maybe they could improve the process, because how a data entry clerk works. It's not a person, you know, so efficient with typing as UI. So we can type your JavaScript, you're typing, talking to a friend, sipping coffee, and you're still typing. This is not how they work. They work in this manner. They have a piece of paper, they take a look at the paper, then they take two fingers, type, looking at the keyboard, then they take a look at the monitor. And the cycle goes on, like paper, keyboard, monitor, paper, keyboard, monitor. So the smart guy said that they should apply this. Do you know what that is? It's a PC speaker. It was a little thingy in our computers which did beep if the computer operated, or beep, 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 beep if there was an issue with the CPU, for instance. And they thought, the smart guys, that maybe the computer should beep, beep if someone enters a wrong data into the computer, basically. So people are saved one step from this cycle, so they don't have to take a look at the monitor, they can just take a look at the paper, keyboard, They delivered that, they shipped that, it went into production, and the performance dropped. Some say 30, some say 40%. What was the reason of that? It was the culture of the data entry clerks. I don't know if you have any Far East companies in Kyiv or nearby. We do. My wife works for one of such companies, and respect works in a bit different way than in our culture. I mean, it means that respect is something you have if you're in a position, sorry, in the hierarchy, you have a higher position, or you're older, or you're a father, and so on. The respect is just granted, right? So it's not like with our culture, if you make a mistake, it's like not such a big deal. Or when your computer beeps, it's not such a big deal. But in that culture, just not to lose this respect, to make sure that nobody knows that you made a mistake, to lose that respect, you don't want your computer to beep. Because if it flashed at the monitor, only you knew that there was a mistake. Now, when it beeped, the half of the room knew that Mr. whatever his name was made a mistake. And this is something you want to avoid, living in that culture. Therefore, you check the monitor even more. So instead of the gain in the performance, there was a drop in the performance because of that. Another similar example, there was an attack. There was an attack, and some agency from United States, FBI, CIA, or another 3 letters acronym said that it was bloody Russians, that the Russians hacked us. And there was a dementi, a denial, a few days after, saying that it wasn't us Russians, it was me, and I am a smart guy from Italy, and I, a single guy from Italy or Spain or Portugal, hacked all of you United States, ha ha ha. Thing is, the 3-letter agency, after reading this denial, said that it was the Russians. And why did that happen? Why this dementi even confirmed the agency that it was the Russians? When I get something like this, it means to me that it was written by Paul or by someone from the United Kingdom or a German or from the United States. I know it, okay? But when I get something like this, you guys smile. You already know the answer, right? So this was the mistake they made. Because of their keyboard, your keyboard, they didn't write it this way, they write it this way. That's why when Americans saw this, they said, okay, it was someone using non-Latin keyboard. Obvious, despite the message was written in Italian English. When I get something like this, mind the space here, it means it was most probably someone from France. Because this is what they do. They put space in front of exclamation mark, question mark, and so on. Therefore, just by the way, like, emoticons or other characters are used, you can tell the culture the writer, the sender of the message is coming from, which means that cultural context matters. It's in us, it's in our users, and it's in us as a programmers. And we you know, in these days of globalization, we need to make sure that both contexts match each other. Or at least so we are not so detached from the culture of our users, so we don't put a PC speaker into use. Last story like this, I work with David, and David used to make little pages, you know, in Drupal, in Django for small companies in Poland. And there was a time for user acceptance testing, so he sent like login credentials to secretary, and the secretary was supposed to perform the user acceptance testing. And he said login credentials not by a snail mail, like traditional paper, only by email, like we all do, which is not exactly the best way, but anyways. So she received this password and login, and she was quite into computers. You know, she wasn't typing with 2 fingers. And the reply was, it doesn't work. Yes, it does. No, it doesn't. It works for me, you know, the standard answer, but doesn't work here. There was like a whole week of a ping pong. Works, doesn't work, works, doesn't work. And, you know, David was so desperate that he even thought that maybe I should just, you know, quit and go to Siberia. I don't know. And like, as a last line of resort, he established a screen sharing session. And he told the lady, okay, show me how you log in. And the lady started to type the password. When you guys receive a password by email, what do? Exactly, you copy and paste. And so would she normally, but this time she started typing. So David asked her, okay, but why don't you just select and copy the password? Because I can't select the last dot. Which dot? There's no dot in the password. Well, of course there is. The last character is a dot. No, there is. I didn't send you, but I see that. Any guesses? No. And the funny thing is, when the lady saw this dot left by a fly, in any other situation, in any other context, you know, Excel, spreadsheet, Word, Facebook, she knew, or her brain recognized it as a dot left by a fly. In this very position, you know, the password was displayed by Outlook in a way which made the dot appear as if it was the last character of the password. So sometimes, guys, the context is really freaked up beyond any recognition. Again, we need to find it. Okay, we're switching to the second part, and I owe you a little explanation. So I was working in one role. One role was recruiter. I used to recruit people. I used to ask people questions and just to figure out, you know, about their level and so on. Not if just efficient in like microservices, blockchain, what are the modern Kafka and stuff, you know. Whatever there is, the fancy schmancy technology of the time. I also wanted to like understand if they understand what's going on behind. The other role is I'm a bootcamp teacher sometimes. And you know, do you have any bootcamps in Kyiv? Do you know how it works? Bootcamps. Bootcamps, okay, I see you guys are nodding, okay. So there's this young, eager person who paid a lot of money, and this person is asking simple questions to a guy like me with 15 years of experience in Java, and expects, okay, I gave you a simple question, I want a simple answer. And sometimes they don't comprehend that the best answer starts with "it depends." They just want a clear prescription, clear answer, simple question, simple answer. So sometimes it took me like 2 or 3 days to explain to them that answer starting with "it depends" means that I care for them. And I want to give them the best possible answer, not just like, you know, a lie for children, like, you know, a bad wolf will eat you and stuff. So this is about this. So let's assume this is this recruitment process, and I'm going to hire some of you, I hope. So this is the question: which sorting algorithm is the best?
It depends what kind of data you have, and it depends what additional requirements you have on the sorting.
You'd get hired, mister. Really. Unfortunately, I can't hire you. I don't have any spots left, but I have jellies. It depends. The answer I hear from super duper junior programmers is quick sort, or sometimes merge sort. This is what they think. The fastest sorting algorithm is quick sort. This is the answer they have for me as the recruiter. This comes from videos like this. Let me play it for you. So it starts, you can see we have 100 numbers to sort. Quick sort, insertion sort, merge sort, and bubble sort, and other algorithms. Quick sort 1. Again, quick sort 1. Again, quick sort 1. And the last one, oh, there's the insertion sort, but quick sort 1. Okay. I see 2 problems with such videos. First, it's the music. I mean, why do you put such a music to this video? Another is, I have a question for you. Who in this room has such a business need, a business case in your real production software that you guys are sorting numbers from 0 to 99? Exactly. This is not the first time I'm giving this talk, and so far nobody has raised his hand or her hand. Really, I believe I'll meet this person one day, because this might be a valid business case in some rare circumstances. But it's not the usual business, right? This is a made-up example for academia and for videos and a background for your loud music. So what I did is like I forked this solution and I turned it into more real example, like this. And insertion sort 1. Bubble sort also sorted. Quick sort is the third one. Any Scala programmers in the room? Okay, one guy. In Scala, for sets, we have special implementations for sets which are empty, 1 element, 2 element, 3 or 4 elements. It's starting with 5 or 6 elements where Scala under the hood employs a hash set. You know, collections with so few elements are so popular that they even created special implementations for these situations, because these situations are the most typical situations. So we are rather not going to sort 100 numbers perfectly distributed, but 100 times we're going to sort something like this, what I have shown you, 4 elements. Therefore, sometimes, let me click it, sometimes, you can check it out on GitHub, sometimes sorting like this, which is 1, 4, 2, and 3, can result in 5 comparisons in bubble sort and in 6 comparisons in quick sort. You can check it at Visual Algo if you don't trust me. And you can see if your comparison is costly. Let's say you have many situations like this and you can't cache the values. You always need to pass the string to perform the comparison. Then it means that comparisons are something you would like to avoid because they cost you, basically. Because getting this representation, which cannot be cached, is costly in this very example. Factors, as you started to point it out, initial order of the data, keeping initial order, data set size, cost of comparison of 2 elements, cost of swapping 2 elements, this one with this one, and we need to swap them, cost of inserting an element in a list of array, or cost of index-based access. In lists, it's easy to insert an element. You just, detach 2 elements, insert an element, wire them up, and it's working. In arrays, on the other hand, it's really easy to find an element at a given index and to swap the elements, right? It's not easy for lists. Cost of additional memory if you have an accumulator in merge sort or something, and so on, and the story goes. So this is the answer to the question, which sorting algorithm is the best? It depends on all this and even more. There is no the best algorithm if the data is unknown. Basically, this is my answer. You need to know what you're going to sort, where, when, why, and then you can, start guessing or testing which algorithm is the one for you. The data is your context. Okay, there was a myth in Wrocław in Poland a few years ago about a slowed app. When the app is slow, what's your first guess? The app is slow because DB on Java. I would say Spring, not Java, but anyway. Because of the slow DB. And there was an application, it was called Our Class, Nasza Klasa. It was more or less like yours w Kontakcie or Facebook, more or less. And it was so slow that on Sundays after lunch, people couldn't log in. And this whole app was started by 4 guys, 3 developers and a graphic designer. And the rumor is they hired a database expert who just came in and added a few indexes so we could finally log in to Nasza Klasa. Is this story true? Indexes, my friends, are used in where clause. So if your query doesn't have where, indexes are not going to be used. And indexes are built and balanced during inserts and updates and deletes, of course, during DDL operations, DML operations. And they make sense for fairly distributed values. Like there was a database I saw, and the guy was shipping goods to various locations, and they kept in their database the country code of the country code from the address, right? And 98% was PL for Poland, and they were indexing that. Exactly. you don't do that because it's not fairly distributed. The flatter the Gaussian, or any other distribution is, the better it is for indexing. If you have one huge peak in the middle and just tiny pieces of data around, it's not good choice for index. And things need to be easy to index, like dates, integers, longs, or 2, 3, 4 characters. If you have the whole lorem ipsum or half of the Bible, then it's not going to work well for indexing in database, basically. So indexes are not free lunch. Nothing is free lunch, actually. And ingredients and consumption matter. So I show in the ingredients. Let's talk about the how we can consume it. Let's assume you have a simple application and you have invoices, and you add many invoices every day. And every time you add an invoice, an index is going to be rebuilt. Black, red trees and stories, so the story goes. And then at the end of the month or at the beginning of the next month, there's just one query run by your accountant or CFO to get a total. So we are making our database busy for a whole month, building and updating this index, and we consume it only once per month. So does it make our database faster? Does it make our application faster? For that single query, yes, but not for every other user. The way you process your data is your context. So this also applies to indexes. Another question from recruitment. So let's search for another expert. How you can print sorted list, Mester? How can you print a sorted list?
Basically, just iterate through it and do a print line on each element.
And you see, you already have the answer. I didn't ask you. I didn't tell you anymore. Any other volunteers to take part in the conversation in the recruitment process? Nobody wants to change the job? Depends on the context. Okay, so explain what you mean.
You can, for example, make a parallel stream if you have several cores, or just in one stream if you have one core. So
you already assumed I have Java,
yeah,
Java 8.
Of course.
Okay, which might not be the case for PHP. Another expert. We get greedy. Come on.
So what kind of print are we doing? Like print on the paper or print of values in console?
That's the way we should go. Thank you. So we are going to print sorted list of children's names in a typical 3-tier web application. And we have names like this, like Adam, Anna, Hubert, and this is the list we want to see in our mobile phone because we sell GPS trackers for children. And we want the parents to be able to sort the list in their smartphone where the kids are, basically. This is our application. And I'm not very good at drawing, okay, so this cylinder is a database. These are our application servers, and this calculator is BlackBerry, and these are your Macs. Let's assume that this is the architecture of the database. And again, we have to print sorted list of children's name in typical 3-tier web application. So this is the client, then this is the architecture. How do we do that? Okay, you want jellies, okay, but you didn't win the job. And let me explain why. The requirement was print sorted list. And we developers somehow work in a manner, I'll get to you in a minute, that when we hear sorting, ding, 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 and there is a database in the whole ecosystem, we act like a Pavlov's dog. Sorting, ding, 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 order by. This is what we do. This is what happened to you, thanks to academia and your whole education and stuff. And the quest was print sorted list. We print it here, right? Even it's a brick, but it has JavaScript, we can print it here. The requirement doesn't say we have to get sorted list from our busy non-scalable database. It doesn't say we have to pay more for the cloud, which is hosting our application servers. The requirement says we need to print sorted list. So we can defer this process of sorting up to here. And trust me, okay, how? I assume you have a browser which has JavaScript enabled, okay? And that you don't have more than 50 children, for example, to track. Do you know anyone who has more than, let's say, 7 kids? Exactly, that's the case. Such situations are so rare that there is no need to, make our busy database even more busy. If it's only about printing and you have like no filtering or no paging, because the collection is always or almost always going to be small. That's small, like I don't know, 3, 5, maybe a dozen kids. So you can defer this printing up to there, and then you're paying for storage here. You're paying for CPU there, which means your boss doesn't have money for a new Porsche. If you propose such an optimization that the users are going to spend their CPU on that, the boss will be able to buy himself a new Porsche, and you guys will get a bike, maybe. Or the buy is not for free, again. It depends on the database engine, but sometimes you need to create like a temporary table, you need to open the cursor, then you need to clean after, and so on and so on. It makes the database more busy. And if you don't need it in the database, you can avoid that. There was a comment. That's also a valid case. The sorting here depends because we have assumed this is Adam, Anna, Hubert. And if the collation, the alphabet changed, it depends on that. That's why it's very nice to avoid it up to there. And another thing, if you decide to sort in the opposite order, like from Z to A, you don't have to hit the application server and the database again, right? You can just sort it here because you have all the data. I assume you're using something like, jQuery or something, so it's like no special app for one system or another. Another mantra, the purpose of data of your data processing is your context. Another mantra, every 2 or 3 years when I go to big Java conferences, I hear something like this: interrupt in Java is broken. Or developers sipping coffee talk to themselves, interrupt in Java is broken. Man, it's so broken. You have to call this bloody interrupt again when you call the exception, and this whole ceremony and blah, 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 yada, yada, yada. Is it really the case? You've heard the story. You're smiling. You've heard the story. Now, guys, maybe you've seen that. I hate walls of text. I hate PowerPoint karaoke. But I think in this very situation, we have no other choice. So let's read it loud. An interrupt is an indication to a thread that it should stop what it is doing and do something else. So it's an indication it should stop doing something and do something else. So let's assume you're asleep. You're a thread, you're sleeping, you're waiting, you're computing something. And I can interrupt you, which means, please stop. It's up to the programmer to decide exactly how a thread responds to an interrupt, but it's very common for the thread to terminate. So usually we terminate threads to kill them, but it's not always the case. So for these 2% of cases of different contexts, it makes sense not to kill the thread after interrupt. This is the usage emphasized in this lesson. So they were teaching people how to interrupt thread to kill it. But there are also other usages possible, like you can reuse threads, for example. And you know what I like the most in this wall of text? This link. It has essential in name. This is essential knowledge about threads in Java. Really. In other words, this means this is what interrupt means to a Java thread. A thread is sleeping, waiting, doing something, and I'm approaching the thread and saying, hey, may I have your attention, please? And then a thread responded. And then in the next sentence, I can say, go kill yourself. We assumed you're a thread, okay? You assumed you're a thread. And this is what we actually do most of the time. But sometimes we don't want the thread to be killed, to die. That's why this is what it means. May I have your attention, please? It doesn't mean stop. This method is deprecated, like for ages. Or it doesn't mean destroy. This method was deprecated before it was implemented because it's not implemented. It never got implemented, but it's deprecated. And it's not possible to interrupt, to stop, to kill a thread in Java in a generic way because of the monitors, state logs, unwinding stack, and so on and so on. It's nicely described in this article if you're eager for more knowledge. So interrupt doesn't mean die. Interrupt means, may I have your attention, please? I hope I cured you from this mantra that interrupt means die. Another example, transactions are a must. If you have a serious system, any serious system, you must have transaction in case you need to keep data consistency, and you always want to keep your data consistency, right? And this always comes from this academia, like from universities or from these books when they teach you databases or they teach you like parallel things or concurrent things. What's the example? Sending money in a bank, right? That's the example. So you have two accounts, you open a transaction or you set a log, you subtract some amount from one account, you add it to another account, and you finish the transaction. Have you ever sent money from bank to bank? Do you think they have a common transaction for both systems, for both databases? Exactly. Yet the bank transfers work somehow, and they don't have transactions. And more or less the system is consistent, right? I mean, it's not consistent instantly and all the time. Sometimes they do bad things, but eventually they will get consistent. So there's a valid working example. They don't do this like in these Hollywood American movies. So the client comes to a bank, I'd like to transfer 1 cent to Cyprus. So they don't go to Cyprus, and they don't come in, everybody freeze in the other bank. They don't call their bank, okay, we froze all their transactions, send the money. And the money doesn't come in second track. And then after the whole thing, they don't say, okay, you can resume your operations. And they don't come back, these times without signal. This is not how money transfers work in banking system. They don't have transactions. Yet the data is consistent, more or less. So maybe transactions aren't a must in your system. There's like this whole transactionless buzzword, or this leads to questions that we need transactions so much that people are asking such questions on Stack Overflow. How do I ensure transaction in our REST microservices? And it's like, it's an oxymoron. It completely violates the idea of microservice, to have a transaction spanning many microservices, right? Because this is what we wanted to achieve with microservices, to get rid of this huge monolith. And yet we are so deeply thinking about transactions and consistent state at the end of the request that people asking such questions, microservices and transactions, and across. What is the most accepted transaction strategy for microservices? Better question, but still it has like, someone knows that there might be not a transaction, but still they think in terms of transactions. Not consistency, but transactions. If it was like an accepted consistency strategy, that would be a perfectly valid question, I think. Or, there's like how I avoid two-phase commit, or eventual consistency and more. So this is really like, widely researched topic in IT. So we don't have to have like begin transaction and commit. Really. There's also CQRS with this whole command thing at the beginning. And the rule is, if you have any command, if you have to log one thing, it's okay. If you have to log two things, like two tables in your database, it might be okay, maybe not, but might be okay. But if you have to put a log on 5 tables in a single command, it means your model or your command is seriously broken. Or maybe you could even drop database. and go, people are going data serverless. Maybe you should go database less, like Jarek Ratajski is doing. He has a talk on this, on drop database. When demanding a transaction, make sure you don't do too much. You don't demand too much consistency. And Black Friday, the perfect example for today. Optimization, it's a Black Friday, and your system is crashing, and these are the logs, the utilization of your CPU, of your router. And what can you do? Which color is the most dominant in this picture? Black, you were the first one. Catch. Black, exactly. People instantly start thinking, why is there so much red? Maybe the CPU is waiting. Maybe these are dropped packages in routers, something like this. And they start thinking, is it just a coincidence? Or maybe not, and we're focusing on this drop and on this peak. And we miss this huge black part. This is the room for rapid optimization. So we should go maybe like this. See? In the long run, okay, the day after Black Friday, we want to get rid of this rag and maybe this correlation. But when we have to fix it right now, what we can do is just get rid of the black. This is our context. This is the context, right? This is the context, not this. Yeah, make sure your context is not too narrow. Now, 2 simple techniques of finding and determining context. How you can do that? You can just go why, and why, and why, and why, and why. Does it ring the bell? Do you recognize it? 5 why, exactly, 5 why. An example, you're a manager, like in a shipment factory or something, or a factory in a shipment industry, whatever, and you're going across this big hall, and you spot some piece of oil spoiled on the floor, and you can go, hey Johnny, clean this up. Okay, solved. No oil on the floor, right? Or maybe not. Maybe you should ask, hey Johnny, why is this oil here on the floor? And the answer might be, boss, because the pipe is leaking. Okay, Johnny, why is the pipe leaking? I don't know, I'll check it out. 2 days after, Johnny comes, boss, because the pressure is too high. Okay, Johnny, the genius, why is the pressure too high? I don't know, I'll find out. And an hour later he comes, it's because Joe is putting not 1 crate on the ramp, on the loading ramp, but 4 crates. So it's too much load, therefore the pressure is too high, therefore we have the leak. So as you can see, the actual reason is not the oil on the floor, but it's Johnny not respecting health and safety. Sorry, Joe. See, so we have to dig for the reason. So if somebody comes to you, your product owner, and says, hey Ivan, I need this big red button here in our page. You just don't go and implement this big red button. You ask, why? This is what you do. You don't clean this up. You search for the context, to get to this highly paid consultant role, mind you. A bit more advanced, some say it's Fishikawa, and actually the full name is Ishikawa Fishbone diagrams. It comes, if it has a fishbone, it must be Japan, right? It is. It's also called cause and effect diagram, and this is an example how it looks like. I think if it was invented in Poland, it would be called Christmas tree diagram, because if you tilt your head, it starts looking like a Christmas tree. An angel sitting on top. So here's an angel. There are the big branches, then smaller branches, up to the very small needles. This is more or less like a fishbone. And you have the main defect here. And you search for the reasons. And you have a personal materials measurements and so on. And for personal, you get deeper. So we have operations, training, shifts. And from shifts, you can get even deeper. So it's like 5Y, only not in a single direction, but spreading, to get all the possible reasons, all the possible causes of our effect or defect or whatever. So if you have this big red button here, sometimes you need to go these ways to find out what it's all about. Now, do you want more? There are more mantras we believe, like composition is good, inheritance is not good. Or Java is slow. There's such a mantra. Or Windows is an operating system. That's also a mantra. And there are more mantras. And does it mean that we shall always search for a context now? Let's assume that you go to your office on Monday and you approach your boss and you say, hey boss, I was attending Devoxx and there was this funny guy from Poland and he had a saw and he said that we are doing our sorting wrong. So we should revisit our sorting and we should do the sorting properly to evaluate if we should get rid of quicksort and start using bubble sort. No, this is not what I'm trying to tell you. Most probably your sorting is just okay. If nobody is complaining, it's okay. If it's not the core of your business, it's okay. It's just when you teach younger folks or when you're being recruited and somebody asks you, what is the best sorting algorithm? You follow Ken Beck's advice and you start your answer with, it depends. And we had an interesting talk with Nicola this morning, getting here on bus, and it depends is not the whole answer, I mind you. It's not the whole answer. If you say it depends, it means the other person is just a stupid moron. Right? You start your answer with it depends and you get options. You get into these branches or these bones of this fish. So you just start with it depends to give a decent answer to any non-trivial question. You start, it depends because, and here the story goes. You just don't shout out 42 or yes, big red button, yes, yes, yes. Now guys, I like to ask you that you always, and for everyone, provide feedback. Not just me, not just Devoxx Ukraine, any conference, any meetup, any technical meeting, whatever, provide feedback. 2 reasons. First, next time most probably you will see better speaker with better conference talk. And also this is a way of saying thank you to the speaker because we spend sometimes many days or making a presentation like this. And if you're too shy, I can even accept like a traditional paper feedback like this one. One lady was too shy like 2 months ago, and she just gave me this paper saying, I'm too shy, sorry. And she passed that to me. In Polish, it means, I'll be dreaming about your presentation at nights. Good job. So I accept any kind of feedback, really. And guys, thanks a lot. Be aware, because it depends. Spasiba. I think we have a few minutes for questions if you have any, or I'll be here at the after party everywhere so you can approach me if you don't want to ask a question to microphone. No questions? Oh, there's one вопрос. Давай. So the question was, what's the best strategy of making transactions in microservices? The answer is, I would say, it depends and I don't know. Because it depends on your transactions and, you know, so on the way you implement it or somebody has, because it's always not mine microservices who are doing badly, but my colleagues, right? I know that. So sometimes people go from this monolith to micro-monolith approach. And this is usually indicated by this fact that they're asking for transactions, right? If you start to think in a, you know, first it's like this Conway's law. So if you start to think in a distributed way and asynchronous way, then you naturally, like, you know, eliminate transactions. Sometimes in some businesses they are needed and they cannot be avoided. But sometimes, you know, if you need transactions, maybe you shouldn't go microservices in the first place. That's the answer. And for a precise question, no problem, you know, I can get hired, I can take a look at your code and maybe we'll figure out something. Another вопрос. So there was a question, there's an answer, right? See, another highly paid consultant.
So on the previous speech, there was a pattern called compensation. So please dig in this direction.
More questions? Another one, yes.
I think we have this kind of thing. We have the bank transfer, or we have this thing where we book like a train ticket and a hotel. So we kind of have the abstract requirement, but transaction is a technical way to solve it, and maybe there's different mechanisms to have something like that.
Well, I'm not trying to say that transactions are bad, or that transactions should be avoided at all cost, or that if you have a transaction, you guys suck. It's not what I'm trying to tell you. It's just not everything should be done with a transaction. And sometimes transaction is like, you know, if you have a leak in the pipe, transaction is just a mop to clean the floor. Sometimes it's okay, sometimes it's not, and it's up to your context, you know, so you don't believe in the mantra that transactions are a must. Sometimes they're good and valid and perfect and the best solution, sometimes not, and that's the story. So I'm not saying that quicksort is bad, I'm not saying that transactions are bad, I'm not trying to say that interrupt is bad or not bad, it depends on your context. That's the whole takeaway from this talk. Just to open, you know, some flaps in your mind so you get out of this room a bit more aware of a possible context, I hope. Another front row question.
Yes, so it's really common if we define our context in a wrong way. So what can you suggest in order to rectifying our error?
These simple two techniques. First is the simple way is this why. Really, this 5 why technique, approach, rule, whatever you call it, saved my bottom many times. And it also depends on the way you ask the questions. Sometimes it's not just why, but you know, you need to, because there's like a superior or the client, and if you just ask why, they might feel insulted or something. So you need to do that sometimes in a politically correct way, let me put it that way. But you just need to, you know, search for the reasons. Of course, there are sometimes situations where you can't or you shouldn't, like, I don't know, for instance, in banking. Let's say you're working in a foreign bank and they have totally different rules when it comes to banking. So you will not make a PhD for a few years to ask them valid why questions. Of course, in this context, they have their business analytics and they will tell you what you should do. And maybe you should ask why to not to the bank owner, but to the analytics, right? But sometimes you can't answer the question, ask the question, but many times you can just ask why. And you know, if this single 5 why path is not enough, you can just go, you know, to spread the thing in this Fishikawa approach. I recommend both techniques, depending on the, you know, how difficult the task, the context is. Is it okay? No, quite? Okay, we can talk later. You know, maybe the problem is that, you know, there's a joke in Poland recently that, you know, there's our Ivan is Jan or Janek, and the boss is saying to Janek, you should sometimes, you know, stop coding in the computer, you should go talk to people. And Janek says, boss, I studied IT for 5 goddamn years just to work with computers, not the people. And you know, what I'm trying to tell you here as well is that sometimes you need to work the people, because you can't ask why to the machine. You can use the machine. You can type email. You can, you know, call them on Skype or something. So computer is just a communication channel. But at the other end, you know, the receiver of this why questions is just a human being. So it requires some communication, interaction, you know, so-called soft skills. And many of us are afraid of this. So it also takes some practice. That's why it looks scary, because, oh, maybe I should just implement that in Spring, you know, why should I ask them? More questions? I think we are running out of time. Okay, and we all need coffee. Thank you very much once more.